Hey guys, BuildZoid here, and this is just like a evidence video because, well, I've known for a while that the switching frequency setting on the Unify X does some very, very strange things to the core voltage, but today I want to I want to record it so that I don't have to doubt my own memories because it's insane what it does. So, according to the data I have gathered so far, with 1.43 volts and mode 8 LLC 500 kHz switching frequency, we should be seeing 1.24 volts average voltage in Prime 95. So we're just going to save these settings. So this is mode 8, 500 kHz, 1.43 volts. And we're going to run some small FFTs, and it should drop all the way down to 1.24. And we're going to switch it over to 1000 kHz, and I'll either find out that I'm going crazy or this board is crazy. Because, yeah, like, I tried to, measure this earlier, and the result I was getting was, like, I thought I set something wrong, or, like, I forgot what settings I was running, so... Yeah, and we go down to 1.24 volts, as expected. Right, if I wipe out the, 1.24, it's even dipping down to 1.23. As the CPU heats up, I imagine like the voltage will actually climb up a bit because the CPU starts pulling a bit more current, and also the socket impedance probably gets a little bit higher as the temperature of everything goes up. But yeah, so this is 1.24 volts. Okay, so that is matching my data that I've recorded so far. So there's no mistake in what I recorded. So what happens when I switch it over to 1000 kilohertz? Okay, 1000 kilohertz, here we go. Mode 8, 1000 kilohertz. 1.43 volts. So far, I'm not seeing anything particularly concerning, and I don't expect to until we try to run Prime 95. Okay. So, Prime 95, small FFTs, and go. Okay, I'm not crazy. The LLC on this board is just like, what the hell? Like, we're averaging 1.31 volts. Like, this is totally uncoolable at this point. Wait, what? Why did it come down later? What on earth is going on? Why is it... Like, that is so weird. Okay, I wanna see what's going on, because this... Like, it might have started throttling. That wouldn't surprise me, because 1.3... We're on a 240mm AIO. There's no way in hell it's cooling 1.31 volts on the back of the socket. Now it's at 1.23. What? Now it's at 1.3. What? Oh no, it is overheating. Man, the VRM is having, like, a seizure or something. Yeah. Like, the VRM is just totally freaking out. Why the... Like, what on earth? Okay. Let's try that again. And yeah, it just overheats, and then, like, what the... Like, okay, so basically 1000 kilohertz on mode 8 is just completely broken. Like, that is broken. Like, there's no other words I could think of. Like, that shouldn't happen. I have no idea why it's happening. It doesn't, like, this is not okay at all. Okay, so it's going to like 1.31 volts. So theoretically, it should be fine if I set the voltage from 1.43. We're going to need to go down, what is it, 70 millivolts. So 1.35. Which is ridiculous. Also, this is on the A22 BIOS. It's possible that MSI changes this behavior with BIOS updates eventually. We're gonna pull up hardware info again, because yeah, I don't know what's gonna happen. So I want to make sure that like we don't break the CPU. Well, I mean, I don't know that I would care that much if I broke this 12900K. And now we're getting 1.2. What? Why is it jumping around? Like, our temperatures are sane now-ish. It's still, like, there is less V-droop. The voltage regulation is fucked. Yeah. What the... Like, yeah, this is really bad. Wait, okay, no, it hasn't locked up yet. Like, the voltage is just jumping all over the place. For, like, no apparent reason. Like, right now we're at 1.236. And yeah, moving the mouse around, like, what on earth is the board doing? Sorry, hit the mic there. Okay, so maxing out the switching frequency on this board is a horrible idea. So that's interesting. Okay, is it equally fucked if we use other switching frequency settings? Let's go back up to 1.4 volts. Let's try, I don't know. Let's try 800, right? Like, that's a relatively reasonable switching frequency setting. Okay, let's hit it with Prime 95. Small FFTs. I'm getting 1.2. No, it's still... Why the... Like, it's still... It's nowhere near as bad as it was at 1,000 kilohertz, but it's still... Like... So if I don't move the mouse, the minimum voltage is 1.21 volts. And then it... Yeah, okay, now this is not okay. Like... I have no idea what the board is doing. Yeah, okay. Like, already on the Torpedo EKX, which, admittedly, I didn't test that board all the way out to its, like, droopiest LLC setting. But already on that board, maxing out the switching frequency, or even just raising it at all, is just a terrible idea. Based on my testing with that board. But this right here is something else. Like, this is so bad. I don't know, 600 kilohertz? Maybe it like, the thing is, like, if it clears up at 600 kilohertz, I feel like you should just be at 500 instead. Like, assuming it clears up. Yeah, so this kind of explains why I was having a hell of a time trying to stabilize Prime 95 small FFTs on this. Because the board just, like, it just does this. Like, I don't even know what this is. Like, this doesn't make any sense to me. 600 kilohertz... It's nowhere near as bad. I wouldn't say it's great, though. Though at this point, I kind of suspect that, like, it's not getting worse, is it? If I reset the monitoring... The fact that like, if I reset the monitoring, don't touch the mouse, the minimum doesn't really get any worse, right? Like, it's still dipping down to, like, 1.119. If I move the mouse around, it doesn't actually get significantly worse, but the voltage still seems to be, like, moving around a bit too much for small FFTs, in my opinion. So we're going to restart and see what happens at 500 kilohertz. Restart anyway. I mean, I recorded 500 kilohertz at the start of the video, and I'm pretty sure it was rock steady, but now it's like, maybe I just wasn't looking at it hard enough. So this is really interesting. So Gigabyte actually uses the same voltage regulator, like, control chip. So this is a Renesas RAA 229131, I think. Yeah. Yeah, RAA 229131, yeah. And Gigabyte doesn't give you access to switching frequency settings on any of their boards for Z690. And I'm guessing this is why. Like, I'm guessing because I'm guessing they tested this, they realized that ultimately with this chip you would probably have to, like, drastically, like, it wouldn't just be changing the switching frequency anymore, you'd have to redo the control loop of the VRM entirely. And so they just removed the option, which is kind of interesting because on a lot of international rectifier actually, I'm pretty sure Gigabyte had 300 kilohertz be optimal on some boards in the past as well. From international rectifier. I think it might just be like Asus and EVGA boards where changing the switching frequency did actually do nothing. As in, it didn't make the VRM run any better, and I didn't make it run any worse. Anyway, here goes 500 kilohertz. Okay, no, like, the mode 8 LLC is evidently just not super steady. I'm gonna pull up Task Manager because we need to be at 100% load. And we are. Yeah, all the cores are maxed out. Yeah, so mode 8 is a bit of a mess. But that's fine, like, well, I don't know. Let's switch over to mode 7. Because... Yeah, so I guess mode 7 is probably best on this board. The thing is, even on mode 7, 1000 kilohertz does strange things. Very strange things. So we're going to go over to mode 7. I wonder if it's connected to the VCC Sense thing. Oh, man. Oh, I so don't want to test that. If it is tied to the VCC... Like, this was a thing on, like, Z490 MSI boards, where depending if you were using VCC Sense or Socket Sense, you had, like, completely different load line slopes, which is... Like, that shouldn't happen. Oh, man. I think that's the correct setting for mode 7, off the top of my head. You know, we have headroom. Let's give it 1.37 just in case. Yeah, but I like... I'm guessing Gigabyte basically tested this, and they realized that, wait a minute, we'd have to, like, write custom control loops for every single switching frequency setting, and so they just didn't give you switching frequency options. Whereas MSI just kind of left the switching frequency setting in the BIOS for reasons I don't understand at this point, because it's just worse as far as I can tell. Yeah, so we get 1.25, 1.24 volts like this. Yeah, this is nice and steady. Yeah, so mode 7 works well. Okay. At least I remember that much. Honestly, at this point, I kind of feel like I prefer the monolithic power systems based VRM that's on the Torpedo, which is just like, that's such a weird. The one concern I have making that statement is I'm not sure how comparable the measurements from the Torpedo are to the Unify X, right? These are completely different boards, completely different VRMs. This is an 8-layer PCB, the Torpedo is a 6-layer PCB, so it's entirely possible that this board actually just lets a lot more noise to the back of the PCB where I'm taking my measurement than the Torpedo does, just because the PCB has less impedance to everywhere, which would actually be good because you have, capacitors on the back of the board that are supposed to help with filtering the power delivery for the CPU. So if there's less impedance to the capacitors on the back of the board where I'm measuring from, then that actually means those capacitors are more effective at stabilizing the voltage supply for the CPU. But, yeah, but consequently, if I'm taking a measurement from there and there is less impedance, then that means we're going to be seeing more noise than on a motherboard that has a lot of impedance to the back of the socket, right? Anyway, let's try 1000 kilohertz now. Kind of makes me wonder who has the, like... So I've already tested the Apex, but I've just not done it on video, and I didn't really take it. I don't think I took any notes. The other issue is, again, like, the board impedance is just, you can't compare motherboards based on measurements from the back of the socket, which really, really annoys me. Anyway, here goes small FFTs. So we are getting more voltage. I think the workload's different, maybe. What FFT size are we on? Oh, we're on 100K, so... What on... Are we not loading all the threads properly? Wait. No, it says 99%. I move the mouse around. Okay, well now we have, like, visible undershoot on the waveform when I move the mouse, so that's not great. Also, our average voltage is higher than it was with the 500 kilohertz switching frequency, so, like, again, that's just not really supposed to be happening. Like, your switching frequency setting shouldn't be affecting your voltage setting like that. Okay, so yeah, so that's not great. Now we're going to try socket sense versus VCC sense. We're going to go back to 500 kilohertz because I think it's pretty clear at this point that 1000 kilohertz on this board, I don't even know why it's in the freaking BIOS. Like, and the funny thing is, like, I seem to remember there were MSI motherboards where they didn't give you these settings. Or actually, maybe it was that they had them and then they removed them, or it was just broke. Actually, no, it was just broken. Yeah, I remember being like testing switching frequency on some other MSI board, not a Z690. I think it was like Z390 or something, where I was like, I was changing the switching frequency and it wasn't really doing anything at all. Like, it wasn't even changing the operating temperature of the VRM. And I think eventually I went to check with the scope, and it was because the switching frequency wasn't actually changing. Anyway, let's try socket sense and see what happens. So, there's two options here. The voltage is now going to be way lower, or nothing changes. Both of which are not ideal. Okay, no, nothing changing would actually be fine. If the voltage is now way lower under load, then I've got like way more work to do, because that means we've just changed all the load line slopes, which again, like, that shouldn't happen. It is lower. We're at 1.22, right? Like, I think I maybe set the voltage lower in the BIOS as well. Actually, for checking this, the multimeter would be better than the oscilloscope, because the oscilloscope doesn't have that much. Like, if you're just taking an average voltage measurement, the oscilloscope's not great. I think I did lower the voltage, right? No, it's 1.37. And it was going down to 1.22. Small FFTs, 1.24. Okay, no, so this is another one of those MSI boards where the, like, so my theory on why this happens is that they're switching the Super I/O through like a transistor or something from being connected to the dye sense to not being connected to the dye sense, which, like, you shouldn't do that. Like, the whole reason the Super I/O is so bad at measuring core voltage on like a normal motherboard is because the Super I/O lives in like the middle of freaking nowhere relative to the CPU. And you don't want to be running your extremely sensitive dye sense lines to the middle of nowhere. And so the fact that like our average voltage reading changes based on if you're using socket sense or VCC sense on the back of the motherboard means that like the impedance of the, or actually it might not be the impedance, but, well, something is happening to the dye sense signal. Right? Like, if the dye sense signal was always the same, the voltage regulator should always give you the same results. But if flicking between socket sense and VCC sense is changing our voltages on the back of the board, that means that our voltage regulator is seeing different things based on if we're in VCC sense or socket sense. Which, yeah, that really shouldn't be happening. Like, this is the whole reason why on Asus boards it's actually super easy to identify, or, well, actually I think on newer ones it might be a bit more difficult, but the first Asus boards that introduce, like, dye sense monitoring, those boards have a really obvious, like, op-amp in the sort of VRM area of the motherboard, because you can't just connect the Super I/O to dye sense, which I don't know that's for sure what's going on here, but like the dye sense shouldn't be affected by, you know, a BIOS setting like that. Yeah, no, the voltage is actually just 20 millivolts lower if you use socket sense. So we basically have a different amount of E-droop now. Okay, so, well, so that is potential. So that might have actually shifted around a lot of the LLCs as well. Oh, man. Makes me wonder. I need to check something on the Tachyon after this, I think. Or maybe I'll just ask Gigabyte to tell me what they're doing. But, well, let's try mode 4. I'm just going to pull up my notes. You're not going to get to see them. I want to see them. Again, this isn't a real piece of content as far as I'm concerned. So, mode 4 with VCC sense, 500 kilohertz was 1.235 volts. No, I don't want to test that one. I want to test mode 5, right? Because mode 5, like, you'd think mode 5 is, like, really droopy or something. But it's not. At least not when you're on VCC Sense. On VCC Sense, you set 1.25 volts and you get 1.24 on the back of the socket, which basically means that yeah, like, that's not really much in the way of V-droop. We're going to go down to 1.25. I can't see anything. There we go, 1.25. Yeah, but, like, if you're wondering, I'm actually seeing the oscilloscope overlay on this video. So that's, like, if you can't see something because of the oscilloscope being in the way, that I can't see it either. Okay, well, so now we're on mode 5. Wait, the voltage is going to fall off the scope again. I'm going to have to pull it up a bit. There we go. Yeah, because... So, we're now idling at 1.24 volts. Okay, yeah, this is very different. So 1.25 mode 5 on VCC Sense would be idling at 1.25 volts. We're idling at 1.24. We're 10 millivolts down already, and we're not even running a workload. Oh, boy. Oh, man, that is a huge difference. That's insane. Oh, why? Well, I mean, that explains why I felt like I was testing the Unify X with VCC Sense the whole time, and I was sitting there just kind of going like, these LLC settings don't really make a lot of sense, because the step sizes between them are, like, tiny. Really, really small. Right, like, mode 1 to mode 2 is a V-droop difference of 15 millivolts, which is like, what? How? Like, that doesn't, like, why would you even have settings that make a 15 millivolt difference? Like, what's the point? Mode 1 to mode 2 to mode 3 is another 15, actually, it's not even 15 millivolts, it's 10. It's 10 millivolts going from mode 2 to mode 3, which is like, what's the point in having LLC settings that are, like, right on top of each other like that? And then you go from mode 3 to 4, and it's another, like, 20 millivolts. And then mode 4 to 5 is, like, 15 millivolts. So basically, like, I was doing this testing, and I was like, all of these settings are terrible. Like, they're all not really very droopy at all, so there's a bunch of undershoot. The overshoot's fine, but, you know, of course it is. Nobody, like, we don't care about overshoot here. But the whole time I was looking at this, like, the undershoot is still terrible. The V-droop isn't really changing very much, and I was sitting there the whole time wondering, like, why do we have all these LLC settings that basically don't do anything? And now it's like, no. If you switch over to Socket Sense, mode 1, I'm guessing mode 1 through 5 now have, like, reasonable performance gap, like, reasonable, like, slope differences between them. Well, that sucks. So I guess now I need to go through and test all the different LLC settings, but with Socket Sense instead of VCC Sense. Man. Why? Why? I kind of want to take the board apart and actually, like, see if I can figure out what the VCC Sense versus Socket Sense circuitry is. Because, like, theoretically, like, the obvious answer to why this would be happening is, like, the Super I/O just gets connected in parallel with the voltage regulator, which is, like, that seems just like a horrible idea. Like, I don't think you should do that. Like... I'm not admittedly, I'm not a qualified electronics engineer, but, like, Asus doesn't do that. I'm pretty sure Gigabyte doesn't do that. ASRock might, but, I don't know what ASRock's doing. Yeah, like, if this is actually just connecting the Super I/O in parallel to the Dysense circuitry, like, to the Dysense circuitry in parallel with the voltage controller, then it's like, yeah, that would certainly explain why the voltage regulation, like, changes drastically based on what, like, sense setting you're using, because the, like, it's probably not picking up any noise. I'd hope it's not picking up any noise from, going to the Super I/O. But the Super I/O being connected in power, like connected to the DyeSense, is like skewing the voltage reading, which is bad. Like, the whole reason we have a like dedicated like DyeSense connection is so that it's immune to outside influences to like as much as possible. And then you have this where it's like this is happening, and it's like that. Yeah. Okay. Well, I mean, ultimately, I think if you just use the board with socket sense, it's probably fine. And the volt, like, I have a lot of testing ahead of me at this point, so that's great. But I can't believe they've done this again. Also, I'm surprised they didn't just copy paste what Asus does. Just like Asus already figured out how to do this without causing this. So yeah, like I don't know why you wouldn't just copy that. I'm pretty sure Asus doesn't have a patent on the idea of using an op amp to like copy a voltage from one place to another. So yeah, that's a thing. I mean, to be fair, I think Z490 MSI boards already did this, but I was kind of hoping they didn't do this anymore. So yeah, anyway, that's it for this video. And just in case I do decide to make it public, thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. And as of recently, I also have a Bandcamp for my solo industrial metal background noise project. There's a link to that down in the description below as well. And yeah, Patreon, Teespring, Bandcamp, they all help out immensely with running the channel, so it would be much appreciated if you check them out. That's it for the video. Thank you for watching, and goodbye.